So today we're going to do synthetic division to find the zeros or to factor down a polynomial, I guess is a better way to say that. So in previous videos we've looked at factoring using the algebraic method, and this is still, somewhat algebra, but it simplifies the process visually a little bit. Now I know it looks a little bit busy right now, but I'll go through and I'll show you. So with this one we have 2x to the third power minus 5x squared minus x plus 3, and we want to divide that by x plus 3. So we can go through and do long division with this. And it looks very much so like long division used to look, where you're trying to match up terms to make x into 2x squared or 2x cubed, and then you subtract what you get there, and then you go to each step until you get all the way down to either a remainder or 0. So with this method, what you're doing is in the front here, you're using the divisor, but you're going to use the root associated with the divisor. So it's telling you to divide by x plus 3. So then you say x plus 3 equals 0, and if you solve for x, you get negative 3. So that's why it's a negative 3 out here. So whatever you're dividing by, you basically solve for 0 real quick, and that's the number that you're going to divide. And then you can see the numbers that are up top here actually match the coefficients. So I have 2, 5, there's a 1 here and a 3, and make sure you're taking the negatives also. So 2, negative 5, negative 1, 3. The big thing with this is you want to make sure that the exponents are going down in order. So we go 3, 2, 1, no exponent, okay, or no x with an exponent. If there's one that's skipped, if we went from 3 to 1, we would have to give this a placeholder. We'd have to put a 0 here to make sure that they are still in order, okay? And so the way this works is you bring the first number down, so we bring 2 down, and then we multiply that by what we're dividing by. So we go 2 times negative 3, and we put that up here, negative 6, and then we add straight down. Negative 5 plus negative 6 is negative 11, and then we multiply again by negative 3, and that's where you get positive 33. And then add straight down, so you get negative 1 plus 33 is 32. And then we multiply that again by negative 3. Bring that up here, so we get 9. Didn't mean to go forward. What is it doing? Silly thing. So we get 96, negative 96, and then we add and we get negative 93. So because this is not a 0, it's called a remainder. It did not go in evenly, it didn't go in with like a whole binomial. There's something left over. So we can say, now we rewrite this. So if you notice, these went down. So now it's 2x squared instead of 2x cubed. So it brings it down by 1 degree. So we have 2x squared minus 11x plus 32, and then the very last piece, if it's not 0, is a remainder. So I have negative 93 over x plus 3. So this is the idea of synthetic division. So if we look over here, so we're going to use the remainder theorem, which is brought up right here. So we're going to divide by x minus c, then the remainder is p of c. So we're going to use the remainder theorem to find p of negative 2 for the function of p, where negative 2x cubed minus 4x squared minus 6. So we're going to go through and we're going to divide these two pieces. They're giving us the value for x that they want us to divide by. So specifically give the quotient and remainder for this associated division of the value of p of negative 2. So if our function is negative 2x squared minus 4x squared minus 6, and it's divided by x minus negative 2, then the remainder is p of negative 2. We first do the division using synthetic division, then name the quotient and the remainder. So, and the remainder is c. Okay, so we're going to write our pieces down here with just the coefficients. So we already know we're dividing by negative 2. That's what they've been asking us to do. And then you can see that I have the coefficients negative 2, negative 4, 0, and negative 6. So that comes from negative 2, negative 4. The 0 is actually because we go from cubed, squared, and then there is no just x term here. So I was saying that on the previous screen. If you skip over one of your exponents, you need to give it that 0 placeholder. So that's why there's a 0 there and then the -6. Otherwise, it won't fall in the correct order when you go to do this process. So we're going to go straight down. We're going to have -2. And -2 times -2 is +4. Oh, that should say +4. I forgot my negative there. And then we bring that down. 0 times -2, well, that's 0, right? 0 times -2 again, well, that's going to just be 0 again. And then -6 plus 0 is -6. So we do have a remainder here of -6. So I already know that I'm going to have a remainder. And the quotient is going to be the first piece, what we're starting with here. Well, it's really the only thing left over. That's why we only see that first piece, because we're not going to go +0 plus 0. So with this one, the only thing left over is that first term, which is -2. It's x squared because we're going down a degree. Okay, we started with a cube. When we divide it down, we go down by 1 degree. So here's my quotient. Here's what's left over, -2x squared. My remainder is -6. So when they ask what is p of -2, that is also our remainder. It's just another way of asking that same question. So I hope that helped reviewing and going through applying kind of long division on how to find the quotient and the remainder. I will see you in the next video.